We've talked a lot about inheritance in the previous section of the course. It's time now to talk about composition. Composition is another component of object-oriented programming and is very useful in day-to-day programming. Before we get into that, I want to review another inheritance example before we move into composition. Let's say you're interested in building a computer and want to assemble it yourself. All the parts are manufacturer's products, which have to be purchased and assembled to build the final product, your new computer. Let's look at a class diagram of some computer products or computer parts. In this instance, I have a base class called product. All of my computer parts are going to inherit from product. All my parts will then have the same base set of attributes: manufacturer, model, and dimensions. The width, height, and depth, in other words, all of these items are products, a particular type of product. A personal computer, monitor, motherboard, and computer case are a few parts or products you can think of that would be sold by a computer distributor. Okay, let's build this. I've created a project called Computer Factory with the usual main class and main method. I'll start by creating the product class. I'll select New Java class and create a new class called Product, and I'll start adding the attributes. All of these fields will be marked as private: string model, string manufacturer, int width, int height, int depth. I'll add a constructor, but I'll only include the model and manufacturer in the constructor for simplicity. I'll select Code, Generate, Constructor, and select the first two attributes. Okay, I now have my base class, and next I'll create a couple of the subclasses. I'll add them all to the same Java source file as the product.java file. Remember, only one class can be public, so I'll omit the access modifier for these classes. I'll start with monitor. For monitor to be a subclass of product, I have to add extends product, class monitor, extends product. I'll generate the constructor, which should insert the two attribute constructors, mirroring product's constructor. Okay, that's my first subclass. I'll copy and paste that class to create my second class. I'll rename the class name and the constructor, changing monitor to motherboard. And finally, I'll create computer case the same way. I'll copy the motherboard class and paste it, renaming the class and constructor to computer case. Okay, so my three classes are created and all three extend product. I can say now that monitor has got an is-a relationship with product, meaning that a monitor can be said to be a type of product. That's the relationship between the two classes. And I can quite correctly say that all three of these parts, monitor, motherboard, and computer case, are all types of product. And that's essentially what inheritance is. Inheritance defines an is-a relationship. Composition defines a has-a relationship. Next, let's look at how I'd use composition to create a personal computer. To keep this diagram simple, I'm showing only that personal computer inherits from product. But remember that all of my classes are really subclasses of product. But a personal computer, in addition to being a product, is actually made up of other parts. This diagram shows that a computer has a motherboard, a case, and a monitor. The motherboard, the computer case, and the monitor aren't computers, not in the same sense that they're products. So that's what composition is. It's actually modelling parts, and those parts make up a greater whole. In this case, I'm going to model the personal computer. And I'm modelling the has-a relationship with the motherboard, the case, and the monitor. I've already created the parts, but I didn't really make them different from each other. I'll look at another diagram that shows these classes with some states and behaviours specific to their product type. This diagram shows the three classes that will make up the personal computer. I have size and resolution for the monitor, and I want a method called drawPixelAt so the monitor has behaviour to draw. For the computer case, I'll have a power supply and a method press power button, and for the motherboard, I'll have slots for RAM and cards as well as a BIOS attribute and a method called load program. Getting back to the code, I'll add these members to my parts. I'll start with the motherboard and add the three attributes first. These are all marked private again. Int RAM slots, int card slots, string BIOS. I want to generate another constructor that takes these three attributes but also calls the super constructor. Positioning the cursor below the first constructor, I can select Code, Generate Constructor, and select all attributes, and that will give me another constructor. Okay, and now I've also said this class will have one method called loadProgram. I'll add that as a public method with one parameter, the program name, and I'll just print text out in this method, public void loadProgram, and as mentioned, the parameter is of type string and called program name. I'll add the text to be printed out. That's my motherboard class. Pretty straightforward, as you can see, with nothing particularly complicated there. Now I'll move on to my monitor class and add those fields, size and resolution, int size, string resolution, and again I'll add another constructor. I'll pick the two new fields. Okay, done. What I'm going to do here next is create a public method called drawPixelAt, and it's going to have an X and Y location and a color. I want to use string dot format, which we learned about in the last section. And I'll just print a simple message out, public void drawPixelAt, and the parameters I mentioned. I'll use println and then a string format, and I'll print the location where I'm drawing along with the color, and that completes the monitor class. Finally, I'll finish computer case, which I've said has a power supply and one method, press power button, so I'll add the power supply field. I'll add a constructor using that new field. To be precise, it also uses the model and manufacturer from product as well. And now I just want to create the press power button method. And I'm just going to add a simple print line that says power button pressed. Now that I have all of my parts done, it's time to build the computer. This is the fun part, where I actually create a class that's comprised of the computer case, the monitor, and the motherboard. I want to create another new public class. I'll call it Personal Computer. And the first thing I want to do is add extends product to this class too. Even though my personal computer has a bunch of parts, it's still a product with all of product's attributes. You can use a combination of inheritance and composition to create your model as I'm doing here. And this class won't compile until I have a constructor, but I'll wait to do that until after I've added my attributes. Let's look at my personal computer class diagram again. This will be my personal computer, and I've said it inherits from product, which I've already done with the extend statement. But it also has three fields which are classes. These are monitor, motherboard, and computer case. Let's build this personal computer class now using composition, which means I'll add three attributes. Private computer case, private monitor, monitor, private motherboard, motherboard. We've talked about the limitations of inheritance in Java and how it allows you to inherit from only one class at a time. You could see that you would run into difficulties and limitations quite quickly if your only tool was inheritance. In this case, what I've said is that the personal computer is composed of these three other classes, namely the computer case, the monitor, and the motherboard, hence the term composition. Before I do anything else, I should add a constructor. You can see IntelliJ isn't happy with me because I haven't done that yet. Positioning the cursor after the last attribute, I'll include all three fields. And that gives me a constructor. And for this class, I do want to add some getter methods for these attributes. And I get three getter methods. Okay, that's my personal computer. I've described what I want to assemble. I'm going to end this video here. In the next video, I'll actually assemble the parts together, and I'll look at how to access the functionality of the parts through the personal computer container. I'll see you in the next video.